So today our learning intention is to learn about specific heat capacity. What is that? When we are heating up some object, the temperature increases, and if we provide the amount of the heat provided, we will denote with the letter Q, because it's thermal energy. We provide heat, we give energy, and so it's measured in joules, and it's equal Cm times change in temperature, where M is a mass of the object, C is the specific heat capacity, delta T is a change in temperature. So change as a change in temperature, so it doesn't matter in which unit you take temperature, either in Kelvin or Celsius, because the difference will be the same. So change in temperature is final temperature minus temperature initial. Or T0, usually initial with a 0. So that is a change in temperature. Now, if you rearrange this formula, we'll make specific heat capacity as a subject. C equal Q over M. This is specific heat capacity. So, Q is amount of heat that we give to the object, or take it from object if it's cooling down. So it tells us what is the physical sense of specific heat capacity. It's amount of energy or heat needed to heat up 1 kilogram by 1 degree. So C tells us how much heat or how much energy we need to give to the object to increase 1 kilogram, temperature of 1 kilogram by 1 degree. Yes?
Is the degree in Kelvin or Celsius?
Because it's change will be the same. If, for example, we change from 20 degrees Celsius to 100 degrees Celsius, so difference will be 8. If you take in Kelvin, this will be 293 Kelvin.
Yeah.
This will be 373 Kelvin. The difference still will be 80. So it doesn't matter in which you take, because we're talking about the difference. And for example, let's say aluminium has specific heat capacity of 900 joules per kilogram per Kelvin. What does it mean? If you take 1 kilogram of aluminium,
It takes 900 joules to heat it by 1 degree.
it will take 900 joules to heat it up by 1 degree.
Is Q the energy?
Q is the energy, yes, it's the amount of heat, energy provided.
I don't get it.
So
What does H3 represent? What does H3
it represents how much heat we need to give to the 1 kilogram of some substance to increase the temperature by 1 degree. If M equals 1, change in temperature is 1, C will be equals Q. So aluminium has specific heat capacity 900 joules per kilogram per Kelvin. That means if you take 1 kilogram of aluminium and you will want to heat it up by 1 degree, you will need to give it 900 joule heat. That's what it means, specific heat capacity. So let's consider a simple example. If we take 3 kilograms of aluminium, and how much heat we will need to give it to increase the temperature by 50 degrees, by 50 Kelvin. So we do Q equal C 900 times mass times 3 times change in temperature times 15. So it will be 135, 27 and 5 and 3 zeros. That many joules of energy will be required to increase to heat up 3 kilograms of aluminium by 50 degrees. Another question, if you take, let's say now water. Water has very big heat capacity.
4,186.
Yes, but we round it to make calculation easier. We'll take that for water 4,200 joules per kilogram per Kelvin. So what is easier to heat up, aluminium or water?
Aluminium.
Aluminium is easy. We need less energy give to aluminium to heat it up compared to water. Water has a big heat capacity. We need to use a lot of energy to heat up the water. Yes?
And the specific heat capacity is determined by the chemical makeup, yeah?
Sorry?
The specific heat capacity is determined by the chemical makeup, yeah?
Yes.
How well it can-
It is, for each substance will be different. Yeah, aluminium has one, copper has another, gold another, water another, air another. So every substance has its own specific heat capacity, yes.
Is it because water has hydrogen bonds, so it's got a stronger...
And like what makes it harder to heat?
Because, first of all, water, all metals is easier to heat. Metals is easier. Liquids harder, gases even harder. Why? Because in metals we have plenty of free electrons. We start going faster and they conduct the heat. As metals conduct heat well, so we'll have low heat capacity. Liquids harder to heat up than metals, and gas even harder. For example, for hydrogen is like more than 14,000. More than 14,000. Because molecules are far away, they rarely, they interact only through the collision, so it's harder to heat it up. Now, so this is a specific heat capacity of water, round. And question is, we take water at initial temperature, 10 degrees Celsius. And we take, let's say, 2 kilograms of water. And we supply 84,000 joules of energy. What will be the final temperature of the water? What will be the final temperature?
4,200.
So to do that,
We find the change in temperature.
we first find change in temperature. Change in temperature will be equal Q over C M. So will be 84,000 over 4,200 times 2. So will be equal 10. Will be equal 10.
Is there like,
So the,
is there something we have to put next to that answer? Like the degree symbol or?
Yeah, we need to answer is because question is what the final temperature is. So at n we have initial in degrees Celsius, we can give answer in the degrees Celsius. So we have found that change in temperature is 10 degrees. Initial was 0, so final will be initial plus change in temperature will be equal 20 degrees Celsius. Make sense? Now much harder question. Now the hard question. If we bring two objects in the contact, we always will be considering there is no loss of heat to environment. That as much heat one object gives, that much heat another object gets. So all heat going from one to another. And let's say we mix water, we mixed let's say 2 kilograms of water with a temperature 90 degrees Celsius. And we mixed it with a 0.5 kilogram of water with a temperature equal 20 degrees Celsius. Question is, what will be the final temperature of this mixture? So we mix 2 kilograms of water with a temperature 90 degrees Celsius with a half kilogram, we added half kilogram of water with a temperature 20 degrees. And so we will have hot water gives heat, the cold water received heat. And as much as hot water gives heat, that much cold water received heat. So let's equalize them. How much heat the hot water will give? We have 4,200 C times mass 2 times final, we will take because it's giving heat, so final will be smaller than initial, so we'll do 90 minus final. Equal, how much cold water will get? 0.5, 4,200, it's still the same. Substance water times 0.5 times final temperature minus 20. Does that make sense how I've made this equation?
Yes.
Amount of heat given by hot water equal amount of heat received by the cold water. And then we need to solve it for final temperature. Specific heat capacity cancels out. We expand brackets, we get 180 minus 2 times final temperature equal 0.5 final temperature minus 10. So we get 2.5 times final temperature will be equal 190. And the final temperature will be 190 divided by 2.5. Use your calculators, divide 190 by 276 degrees. So final temperature will be 76 degrees Celsius. Make sense?
Yeah.
So that's how we work with the specific, what is the meaning of the specific heat capacity and how we solve problem when we have heat exchange, when we transfer heat. That's all new stuff for today. Like, subscribe and donate to help fight terrorist countries and organizations like Russia, Iran, Houthis, etc. Support Ukraine and Israel.